And we're back. Damn good coffee and hot. Yeah, so today I'm gonna take a look here at lookdev in Renderman. So first off, I wanna take a look at how we can integrate Acescg. So Acescg, whoever was at the Art and Science Fair, is gonna be one major thing coming in Renderman 24. But until then, let's take a look at how we can set up the environment variables for that so we can use Acescg at the moment. So yeah, let's dive into that. So yeah, I've seen here, it's an sphere. So yeah, let's take a look here under settings, and we have color management, and we can see here my OCIO profile is set, so that's cool. We wanna now take a look at how we can set that environment variable. So what you can do is, let me see here, save, if I type here and say environment, system environment variables, and looking here at my environment variables here, you see here I have defined a variable called OCIO, and I point this to a path. In my case, I have a path here. If I look at my C drive, I have a path called OCIO Mari. So I took the Acescg config from my Mari, and I'm pointing to this, the config OCIO, and that is then picked up in Maya when I set this variable. Let's see here. So yeah, that's how I configured my OCIO. So let's take a look here. Let's dive into this sRGB here. We can see here I have different type of lookup tables here, sRGB Aces. If I now start to render here, we can see here my Renderman preview render here. It's using sRGB. So let's point my environment light here to something that's actually has an HDR. Source images. Where did I place it? HDR. Let's take cloudy day Acescg. Here's an TX file. It's a cloudy day here. Let's take something else. So what I did, I pre-converted my textures to Aces straight from Mari, and my HDRs is converted to Aces as well. Acescg. Let's see here if it refresh. There you go. Oops, there you go. Okay, so we can now, if I take raw here, for example, that's the linear Aces. This is linear Aces we see in this viewport now, without any lookup table. And we can say, okay, I want to have Rec 709 Aces. That's going to be a Rec 709 Aces LUT. I think my monitor is actually sRGB calibrated, so sRGB Aces is more appropriate for my monitor in my case at the moment. If you would have an Rec 709 monitor, you would probably want to set Rec 709 Aces for it to be properly there. Yeah. Yeah, so the Acescg config is kind of important to set. If you want to render with Aces, you want to have the Acescg config, and the environment lights should also like be converted to Aces at the moment. So that's important. If you have any textures, they need to be converted to linear Aces. So in my case, I convert them from Mari or any other program into Aces when I export them. And then my TX conversion, that's this, if I have an EXR image, it needs to be TX converted to this Renderman format. So let's take a look at that. Let's take a look here. So I have a folder here with some maps here that I want to convert. For example, here you can see here my diffuse color here that I have. Let's take this guy. It's already in Aces my textures. But if I now take this TX icon up here, open texture manager, we can browse. So we can pick a directory. Now let's take source images. And let's take this folder here, sphere maps, and select folder. And it's gonna go through here and look at all of my textures and start to convert them to TX. So that's usually what I do. I pre-convert them to TX before I start to render. So yeah. So yeah, in my case, I have 90 images there that it has to go through now. So it can take a bit of a while to do it. So yeah, it's good to have a coffee when you wait for that. I have 56 out of 90 already done. So yeah. And now you want this time speed up. So it's not an ideal thing to do in live streams when you want to convert textures, but I just want to show now how it's going through. So just to demonstrate the using textures in my workflows. On the asset that I will, after this, take into lookdev is going to be this Gatling gun that I previously textured during my live streams. There's a lot of more textures. I just took this one because it's fairly simple still. And also my lookdev for this Gatling gun, when I texture it using sRGB. I didn't use Aces, so I just wanted to, in this episode, show how to actually use Aces in a way, because when I do it later on, it's going to be sRGB workflows. So my HDRs need to be sRGB as well. It's going to be a bit of a difference, but the same things apply. It's just different lookup tables. Acescg is a much wider color space, so that's why it's used in production or in visual effects, because essentially you're limiting in sRGB, you're thinking of like a triangle. You have red, green, and blue, and it's this, but Acescg is much wider, so you can have more fidelity in your colors, and the intensities will also be preserved much better when you use Aces. So now here there's a few images left, and then we can start to actually do some hook up some textures to this folder. Okie dokie, come on. 86. What's the time? I always want to set the time here so I know what's going on. Let's set the timer. Stopwatch. Okay, so there we go. Now I have all my textures converted. That was in that folder, so we can now start to build something here. So let's just drag this a bit here. Let's take my attribute editor, collapse it. There you go. Okay, so yeah, here's my shader. We can rename it. Let's actually just delete this now to just get this. Let's call this sphere. There you go. So yeah, when you want to use textures now using Acescg, you have here, for example, if you would hit this linearize button, this would linearize to sRGB, so that's a bad thing. That's why at the moment you really have to pre-convert your textures to Acescg. So in my case here, my color map here is already pre-converted. I can slot it in here to diffuse color, and it's hooked up here. We can take a look. Just rotate this one. It's very basic here. If I take this one and hide it, you can see I have some internals here as well. So this is actually my back patio, my garden that we see here in my HDR. So I went out, took an HDR earlier this year under the lockdown here in Windsor, and yeah, I actually took this one, filmed it with my camera and tracked it and inserted this sphere into it just to have something to demo. So I'm already made an Acescg tutorial, so this is a recap, just how to use Acescg with lookdev. Let's make a, so yeah, hit tab and type Pixar texture. That's the Renderman texture node. Let's name it to something spec IOR. Got some strange things happening with sometimes with my interface there. I'm not sure why. I think it's because it's docked. So file name, let's browse for a specular IOR. Let's take name here, specular IOR. Let's take this one. So this one is now pre-converted to TX. I have my Mari file naming there. So specular IOR and extinction coefficient and all of this. So we can take a recap of that as well. I mentioned it in the last live stream. So let's actually take a look at what that is now for the lookdev purpose. So if I start to render this one now here with my Renderman renderer, there you go, and take my sphere here. So we have something called physical and advanced specular. So what's that? Artistic is the way where you have this face and edge color. So if I will make the face color white, it will start to behave like a metal. If you would take this color down to 0, it will become a metal. If you would tint this one to anything, it will pick up the tint and tint the reflection accordingly. With physical, there's a bit of a difference there. So first off, if I set it to physical, we have this edge color, and that's kind of like a gain slider. So you see here, if I set this to 1, it becomes like a plastic now. And we can dial the diffuse up again. My refraction index is now essentially how shiny this ball is. You see, if you go under, it starts to behave in strange. So it's from above 1 is makes sense. So a plastic will be maybe like 1.5 in IOR. Oops. Okay, I can't make it that. I have to have one. There you go. Take 1.5. Oops. Why can't I do that? Ah, there you go. Output. Okay, there you go. Refraction index. So what I want to map now is this specular IOR. So when I texture this one, I actually textured it using physical values. So I'm gonna set my sphere here to physical. I can set my edge color to 1, and I want to pipe this texture now into the specular IOR input. So let's find that one. So I hit the 3 button there to expand it, result RGB to the specular. Let's see, where is it? If I take a search IOR on the shader, and let's take specular IOR. There you go. And there we go. So now we have IOR. You can see that something is happening here. If I zoom in, we start to see that we get some breakup here in. But for this to really work, as I want to define metal versus painted, I need something called specular extinction coefficient. So let's take a look at that. And that's this value, the extinction coefficient, and that's the secondary metallic, and this is what really makes the metallic look. This is what is it? Let's take this one, IOR, and then take extinction coefficient, there, specular extinction coefficient. Let's take another one, texture, sort texture, not random. Whoops. There we go. And we also need a texture, so let's hook up the texture for that one. Specular extinction coefficient. There you go. Now we can see here. If I zoom in here now, we can see here that I have some metallic stuff going on here. Like this one, I painted like it was scratched off. We can take a look here at, if I hide this one, or let's actually drag it out a bit. There you go. Okay, so let's hook up my col map. It's gonna filter on colors. Extinction coefficient. Now let's take my col map, just drag it into diffuse. Diffuse color. There you go. Yeah, so now we have color, specular, and the specular extinction coefficient. So now we need the roughness, and the roughness is how shiny the material is. So take this down, it's super shiny. I take it up, it's gonna be super diffuse. So I have a map for that. So let's take a look at hooking that one up as well. Fix our texture again. Okay, specular roughness. Here we go. Let's take this guy. So yeah, you see here the map ID. This is my numbering. So it picks up this number and it applies this map ID underscore map ID. And I now need to choose here what type of numbering. So it's my UDIMS is Mari. Let's rename this to spec R. I want, so the specular roughness, it's a scalar value. So essentially I just need one channel out of this. So result R in my case is what we want. So let's take spec there we go. Let's zoom in here and see what's going on. So for example, here's a bit of chipped off metal, and then we have different type of you know, roughnesses. And if you want to inspect the map on its own, you can hit this S button. It will solo. So this is actually the texture that I painted. So we can see that the darker value here is going to be shinier, the brighter value is going to be rougher. And also, as this is a linear image, if you want to see what's actually without a lot applied, you need to turn off color management. So you see here this button here, on and off, where you have this, you can set it to off. So this is the values, the linear and the raw values that comes out from Mari when I painted it. So yeah, but that's just a visual thing. It will still be the same values even when I have this LUT apply. It's just if you want to know exactly what values was painted on a scalar channel, you turn this off just to see what's going on. So we can see here it's going to be a bit shinier there, and all of these darker values going to be shinier. So yeah. Okay. Let's turn it on. And let's take a look at the IOR and the extinction coefficient, how these maps looks as well. So you can see here the extinction coefficient. So that's the metallic part of this physical, and we will have values that's above 1 here in these values. You can't see it here, but there is values above 1, so to define the metal. And the IOR value is going to be kind of, yeah, we have values, but this is also a float channel. It's has values above 1, so you can see the metal is going to be the loudest, and that's my dog sparking. You can see these gonna be higher than these ones. So this one is essentially where it was black in the extinction coefficient. It's gonna be like a painted metal, and where it's white is gonna be like a pure metal. So yeah. So that's important. Let's go here. It takes a while for it to sometimes to refresh when I do the solo thing here. Let's see. So yeah. So all of the black stuff here is going to be painted metal, and this is like scratched off. So we reveal the metal underneath, and in between it will be like a blended value. Hello, no plastic, happy to have you here. So yeah, I've been looking at a bit of Acescg and using textures with Acescg, and also yeah, it's gonna be, you can watch it on the rerun later on. But yeah, happy to have you here. Okay, so we have the specular roughness going there. Let's now hook up some displacement and bumps and stuff. So we can, if I take this one and hit the plus sign and go to Renderman and take displace. Let's take, which one should I take? What I usually do, essentially doing like this, Pixar. So I just hit tab and pick Pixar displace. And I hijack this out color. Oops. Let's see which one it connects to. Or we can just do like this actually. Oops. Where is it? Nope, I did something strange there. Out color to there you go. That's not what I want. Okay. Okay, so I want a displacement and I want to displace transform node. So that's a node to displace take values and remap those. I'm gonna show you that. So first off, I'm gonna just set this to, let's go to my attribute editor here and go to my Renderman menu and make this a subdivision surface, because at the moment it's a polygon. So let's set this to Catmull Clark. Should render nicely there then. Have to do it on all of my objects. Catmull Clark. And then on this guy. There you go. So now we have a subdivision. I'm just gonna reshuffle this a bit. Okay, so we want my displacement transform to be, I want to have the result float to this scalar. And then I'm gonna map my Pixar, my texture for the displacement into displace transform here. So I make a Pixar texture. And let's pick up the texture read here. So let's see here. Okay, we can take the bump here just at this moment here. So I set it to more again here to pick up the numbering, and take my result R because it's also float into my disp scalar. So, and you see here it goes super strange here, and that's okay because it's too strong. Whoops, we can see here what's happening with my displacement. So now we want to tweak this displacement. So I painted it, if I look at the texture itself here, if I just go and solo my texture, so let's see here, there you go. We can see here, these are the values, so yeah, it's, let me see here, if I turn off my displacement, if I go back to displace, the displace node here, you can hit this button here which says enable. So that's gonna disable, if I hit it, it's gonna disable displacement. And we can see here something is a bit funky, and it's because I haven't renamed this. So that's a bit of a bug here. We can name this bump. And let's go back and see that I took the right one. The bump. Okay, so let's give it a second. The whole solo thing is a bit, yeah, so there we go. So there's a strange thing here in Renderman for Maya at least. If you have like a texture read node that has the default name, so in my case, if I make it Pixar texture, you get this Pixar texture 1. If you rename your Pixar texture 1 and create a new one that also get this new name, it's gonna essentially somehow mix up the input fields. So that's why you saw that my bump and displacement was going totally mad there, because it actually picked up this one, the extinction coefficient nodes by some way. So I just renamed my texture read to a unique name, and this will, if you just hit the update button, it will pick the right texture. I'm not sure why this is. It's been like this for a long time. Maybe it's just a Maya thing, or somewhere in between, combination of Maya and Renderman. Anyway, so this is the file, and we can see here it's the values is based upon around 0.5. So in my case, if I texture an asset and the middle value is 0.5, this will always be like no displacement. So anything below 0.5 is gonna go down, and anything above 0.5 is gonna go up. So this is a very common way to paint displacements or bumps, that you have the 0 value at 0.5. So now we want to remap this in my Pixar displacement node, and this way use this displacement transform node. So let's take a look at that. So my result R here, we can see here, goes into this displace transform. And this display transform is essentially just a utility node, so remap values. And we have something here, by default is set to none here, so remap mode none. Now it's not gonna remap anything, but in my case I want to have centered. So let's unsolo this, we can see what happens. And let's turn on displacement here again, so we can see also what happens when so now we can see, now it behaves a bit more plausible, but it's way too strong, because the values here at 0.5 and below, you see there, it's just insanely, you know, big amount of numbers here, because you can see here my displays node here is set to 1, my gain here is set to 1. You can either lower this one, so let's say 0.1 is going to be 1/10, and it's going to be more in the line of what's needed. That's even too much. Maybe 0.5, so half of this again would be what's needed. But what I like to do is actually remap the values in my displacement transform node, because when I start to layer displacements, I want to have the ability to still globally raise or lower displacement. So you want to set the first node here essentially set to 1. I always have this set to 1, and then I remap my displacements upstream of it using conversion nodes. So let's do that. So in my displacement transform here, we have this height and depth. So now it's set to 1 and 1. So now it's going to push my values 1 unit in and 1 unit out. So essentially what you want to do is you can set this to, either you set it to there's 2 ways to do this. Either you set it to 0.5 and start to, let's go back and do that. 0.5. Now it's going to push it half a unit in and half a unit out, and then you would mess with this value that's now going to be more like in the lines of 0.1 will probably be something that's plausible. But as I said, I want this to be 1, so I rather actually go here to my displacement transform and set my the range here to something smaller. Let's say 0.1 and 0.1. So you want the same value in and out, because it's remapping a point from 0.5, and now it's going to push it 0.1 and 0.1 in and out. So yeah, let's go in there and see here really. So this is, to me, this is still too much. Let's take half of that. I think that's probably something that's more appropriate for this asset. If I look here, go in. So let's see. Yeah. So now if I would enable or disable displacement here on this guy, you can overcrank it. So it's better to have this gain set to 1 and actually do this in this displacement transform. But what about if I want to layer displacement? So let's say that you want to have a secondary displacement on top. So I have some weld seams here that I want to experiment with. So let's take a look at that as well. So let's create a Pixar texture read, a Pixar texture again. And let's say we want to rename this. I'm not sure why I get this refresh bug there. This welds or something. Janking this will refresh it. I'm not sure. Maybe I need. I think there's a newer version of Maya. Maybe there's something there. Okay, so let's take these weld seams that I have. This weld. let's take this guy. Set this to Mari. And now I want to layer it. So let's first off just take this guy and just plug it in here and see what happens into this scalar there. So there will be, so I have stuff like this, for example. I made like seams around this area here. I think I also have, yeah, we have this, you know, this device here. I kind of have like something bridging that guy there. Oops, and I see that this guy needs some Catmull Clark. So does that guy. Okay. But yeah, I have some displacement that I, you know, like someone that was welding in stuff. So I want to layer that with this other displacement that I have here. So what I do then, if I go back and I take this one as the base, and then we want to layer these on top. So we have something called displacement layer, Pixar displace scalar layer. So we want to hook this guy up instead, because then we can have this in the bottom, and then we have this on top of it. So let's take a look. So I want to rebuild this. I'm just gonna collapse this attribute editor again. Take this guy back so we can see a bit more of what's happening there. So yeah, by the way, it would be cool if any of you want to leave something like a comment after this. If you were attending the Pixar Art and Science Fair, if you saw some of the new features in Renderman, it would be cool if you leave a comment and see if it was. There's also, if you go to Renderman, I think they also have reruns of the streams showing all of the new features that come in 24. I'm really excited to be able to start testing this when it's more closer to beta in December, I believe it's gonna be. So okay, so we want to layer now my displacement here. So let's do that. So I want to hook up my result float into this scalar here and bypass the displacement altogether here shortly. And then I want to take this Pixar displacement transform here. I want to remap this one, take the result float into the base, this base layer, this scalar. And we will now have displacement again. So now we can start to layer displacement if you have more displacement. So now we want another displacement transform going here, coming from this one. So Pixar displace transform, and we want to result R into this scalar and hook up result float into layer 1, this scalar. Okay, and now we see it's totally bonkers, and we can see here this is my weld seams, and we can see it's just too much. So we need to remap this obviously, and we want to take this now here and go here and say remap mode centered. First off, it's gonna shift it a bit, and now we can see the 0.5 value is now not doing anything, so we can see yes. And now I need to go in here and remap these again. So I believe 0.5, similar to my bump, will probably something that's appropriate. So now we have the bump and displacement layered. So we have two displacements. So we have the bump and we also have these seams here. And now if these ones are too strong here, I can either go in here and remap those again, go to my height and depth, or I can actually now in here on the gain here. You see here, we can also enable or disable displacements. You see here, if I disable the layer 1, now my weld seams disappeared. I enable it again. So now you can start to tune them individually here as well. So you can now take the gain on this layer and say maybe it's too strong, so you wanna half it. You can either do it there or you can half it here now, 0.5, and now it's gonna be half the strength of those displacement seams here when it starts to render again. There again, yeah, cool. Let me see here. So yeah, that's a bit about that. Were you able to import a new teapot in Maya? I haven't imported the one that was on the Art and Science Fair. I haven't imported into Maya now. And if I use USD format, I haven't really used it in Maya. I've been toying around using USD in Houdini, because the new Houdini has this Solaris where you can build USD. So I'm looking into learning more about USD, but I'm gonna look into more into Houdini because it's more ready for building USD in Houdini at the moment. But there is USD plugins for Maya. I haven't installed it yet, so yeah. Okay, there we go. So that's essentially the basics of using displacement and textures, and actually also Acescg in Maya. And some of the Maya and Renderman, some of the caveats at the moment is you need to set the OCIO profile, and that's something we already looked at. And I took the OCIO profile from my Mari config. And if you don't have that, you need to go to OCIO, where is it? Let go, so OCIO open color IO. Let's see. Is it this one? No. GitHub. Is this the one? I think this one. Yeah, I can leave a link in the description, or I can link back to some of my earlier tutorials. Oops. Okay, yeah, let's take a look using some other dome lights. Let's take a look at nighttime. If I give it a second, maybe, oops, thought I had a nighttime. Should definitely be something in it. It's overcast. Cloudy, let's take a look. Let's increase exposure a bit and take a look at how it reacts. Let's take this guy and move it. What's going on? Why can't I move it? There you go. Sometimes while rendering, I'm not sure, it feels like I grab stuff that I was not meant to grab. So this will be fun to see when we get this new Renderman with the GPU rendering, because I'm gonna buy a new graphics card here when they release this new NVIDIA card. So hopefully when we get the beta out, I can start to test actually rendering on the GPU, because even now I have a pretty fast machine. It takes a bit of a while. The first iteration is usually the one that takes the longest, and from when I saw the demo, that was really fast, so that's gonna be interesting to see with the GPU rendering. Okay, so now here, what do you want to do if you want to override something? I don't have any ISOs here, but so an ISO is an isolation mask or a mask, but let's say that you want to grade the diffuse color, for example, or the color map, or you want to do something. Pixar color correct, for example. Let's set result RGB to the input RGB. Okay, I want to replace diffuse color there. So now I have a way to override the color here. Let's say that I want to take down a notch the saturation, for example. So let's do that. Acescg. So we have the hue saturation value. Let's just take down saturation to 0.8 and see what happens. Just slightly desaturate it. Let's take it down to 0 so we see that it's working. It's gonna be gray. Yeah. 0.8. So now I'm just remapping the color. And if you want to see this in action, just solo this node and we can take a look at the flat color. So this is the color. It's very simple. It's just some dirt on top of a green sphere here. And we can start to take a look here. 0.7. And unsolo this. Okay, so yeah, that's kind of it for lookdev and using Acescg. So it's a bit of just a recap from my earlier tutorials. I just wanted to highlight how we can use OCIO config, and to recap that, I set this to, and if I type here under my environment, system environment variables, I define my own OCIO variable here. So if I would say new here, I type OCIO and variable name value I browse to a place. So in my case, I just place it here on my system disk here, OCIO Mari. I took this OCIO config from Mari and I point to this one, and that's going to be setting the environment variable for Acescg. So that's what I did just to get that up and running. Cancel. And then you need your textures needs to be pre-formatted to Acescg, and that's something I exported out from from Mori. I exported out from Acescg, and also my lights, my HDR, they are captured on an sRGB. I captured it on this camera. So yeah, and this camera shoots in sRGB. So I had to, when I have stitched my HDRs together, I needed to convert them from linear sRGB to Acescg, and I did that. You can do it in Nuke. I did it in Fusion because I didn't have Nuke at the time. I still don't have Nuke, but now I might actually, there's a like an indie version, so it's a lot cheaper now, so I might pick it up. But anyway, you convert your HDRs or any light, you need to convert it into Acescg as well. So an HDR would be a light, so you convert it from linear sRGB, in my case when I shot it on this one, into Acescg. And yeah, that's essentially about the only thing you need to do to get it to work. And you can also prove that it is Acescg when you go to color management, and it actually picks up here my OCIO config path. Here you can see this is something that it picks up by my well, hold on, you can see here my environment variable. If I go into preferences, it picks it up here. So yeah, that's it. So in the next episode I will go into going back to my Gatling and take a look at the maps and hook this one up. It's gonna be two-part series, one with a monolithic shading like this single approach, and then I will also take it in using a layered shader. So we're gonna have different layers for metallics, painted, decals, dirt, and all of this broken up into individual layers. So we're gonna use the layered shader. So in the first one, it's gonna be a monolithic layering, like a Uber shader, and then it's gonna be a layered shader on in the coming episode after that. So yeah, that will probably conclude it for today. It was quite a short one compared to my earlier last week, but yeah, it's a recap about using textures, converting, and Acescg. Because in the next one I actually gonna roll back to using sRGB, because all of my textures was exported as sRGB when I painted it a few years ago. So I'm just gonna reuse those. But imagine that you could essentially just take all of my textures and actually have an input display transform from linear sRGB to Acescg, and that will also work. I might demonstrate that as well in the next episode, just how to do that, just to recap as well. But yeah, thanks for hanging out with me here today, and see you next Sunday around this time as well. It's gonna do a few Sundays coming up. Yeah, see you. Bye bye.